One key feature of parabolas is the fact that they have symmetry. If you remember from previous grades, symmetry is when something can be split in half and be the same on both sides. For example, a butterfly has symmetry because it looks the same on both the left and right. It's the same with parabolas. We can split them in half and they look the same on both sides. Here are 4 examples. As you can see, in each of these quadratic graphs, we can draw a line down the middle of the parabola and the graph is the same on both sides of the line. It's a mirror image. These lines are called the axis of symmetry because they represent the line where the symmetry of the curve is formed. This is similar to the x and y axis. It's a new axis that cuts the parabola in half. Let's see what this looks like inside the tables of these graphs. Take a moment to analyze the numbers in these tables. Pause the video and think about some things you notice. You may have noticed a trend with the y values. Did you see the numbers get smaller and then at a certain point get bigger again? Did you notice there is basically a turning point where the numbers turn back around? Let's highlight this turning point in each table. Notice how the y values basically match each other on each side of the turning point. This is all related to the axis of symmetry. The turning point is the middle of the parabola, and the graph has the same numbers on both sides of the turning point because the graph looks the same on both sides of the axis of symmetry. Let's go back to the graphs again and mark these turning points. Pause the video again and think about what you notice about these points. The official name for these turning points is vertex. Similar to a vertex or corner of a square, or the vertex of an angle, these points represent the turning point of the parabola. In addition, the vertex of a parabola always lines up with the axis of symmetry because the vertex is the exact halfway point of the curve. Also, notice the similarities between the equation for the axis of symmetry in each graph and the coordinate of the vertex. What do you notice? The number in the equation for the axis of symmetry is always the x value of the vertex. This is because the lines for the axis of symmetry always cross through the x-axis. Therefore, since they always pass through the vertex as well, the equation will always have the same number as the vertex's x-coordinate. Finally, one other truth about the vertex of each graph is the fact that it always represents the highest or lowest point of the curve, and we call this the maximum or minimum value. Again, this is true because the vertex is the exact halfway turning point. It can't get any higher or lower because the graph immediately turns around after the vertex. As we wrap up, let's reinforce the key points of this video. Every quadratic has symmetry, and it can be drawn with a line called the axis of symmetry. The axis of symmetry always passes through the vertex of the parabola, which represents the turning point. The axis of symmetry also always has an x equals equation, which matches the x-coordinate of the vertex. And finally, the vertex always represents the maximum or minimum value of the graph because it's the exact halfway turning point.